Okay, let's talk about machines and work. We're going to talk about how do machines make work easier, even though they do not actually make it any less work. Here you can see a couple simple machines. All right. A machine, at its core, is a device that changes a force. Here we have someone pulling up on a giant weight there, that is changing the force. He's pulling down, it's pulling that up. A wheelbarrow, you're lifting up with a certain amount of force, and it is carrying something even heavier there. Here I have a simple machine that is just turning force one direction into force going the opposite direction. All of those have changed a force. A machine will make work easier in three ways: by changing the size of the force, distance of the force, or the direction of the force. So they're going to change which direction the force is going, and that's what you can see right here. It's going to change the distance over which the force acts. Here I'm pulling up with maybe 2 or 3 feet trying to lift, but I'm only lifting that maybe a foot there, so I'm changing the distance. Or in this one right here, I'm simply just changing the direction. Mechanical advantage is the number of times that a machine increases the input force. Let's explain what that actually means. All right, here you can see just another example of a machine I kind of like to look at here. Again, this, by the way, this won't actually work before you go and try it, but this guy right here is pedaling and the machine is converting that up and down. So it is both changing the direction and the distance over which that force is acting. Just a cool, simple little machine that someone made out of Legos. All right, input force is how much force you're actually putting into a machine. So you're going to want to draw this on here because we're going to be using this for a couple examples here. Input force, so I'm pushing down on this side of the fulcrum, I'm pushing down and that side is going up. Input force is how far, or input force is how much force I'm using to push it down. The input distance would be this part right here, how far I actually had to push it down. So the force is how much force I put into it, the distance is how far I actually pushed it, and the work input is that force times that distance. So how hard I pushed it down times how far I pushed it. That is going to give me my work input. Well, the work output, same idea here. Output force is how much force I get out of a machine. So on the same drawing that we have here, output force is how much force it is lifting that side up. And the output distance, of course, is the distance that it's actually acting through. Once again, you're probably seeing where this one is going to right here. We're going to work output. That is going to be the output force times the output distance. Make sure you add this into that drawing there. So you should have input force, and then this is the input distance. Output force times in the output distance. So here we have another one right here. Input force, I'm pushing down. Input distance is how far. Output force is how much force it's pushing up. And output distance is how far I'm actually lifting that. On a simple pulley right here, I am pulling down with this much force. I am getting that much force out of it. Input force, what you're putting in. Output force, what you're getting out. Okay, in this case right here, I have a guy in a boat. The oars of the boat are acting as simple machines. Now, if you've ever rowed a boat, he's actually maybe just pulling back 3 feet, maybe 4 feet when he's actually pulling that. But the oar is moving with a much greater distance. The input force is how much force he's required to pull that back. Input distance is how far he's going. The output force is how much force the oar actually pushes against the water for. And the output distance, you can see, amplifies it. He's going to be pushing over a greater distance here because of that little fulcrum there, because of that lever. Input force and input distance, what he's putting into it. Output force, output distance, what he's getting out of it. Now, in a perfect world, in a perfect machine, the input would be the output. However, this is not a perfect world. There is no such thing as a perfect machine. Because of friction, what you're going to put in is always going to be less than what you're going to get out. Simply put in equation form, the work input will always be greater than the work output. You always get out less than you put in as a result of that friction. Some of it is always being stolen and lost and taken away. So, machines will make work easier, but they will not increase the amount of work you do. So, you still have to put in the work, and you're going to lose a little bit. A machine just helps make it easier, but it can't make work. So, let's look at this example here. This is a guy lifting a barrel to put it on a shelf versus a guy rolling that barrel up. Now, let's say the weight of this is 75 newtons, and he's got to move it 1 meter up. So this guy on the right just basically has to take 75 newtons and move it up 1 meter. That's what he's doing. The work is going to be the force times the distance. So the force is going to be the weight, 75, times the distance is going to be 1. So he's going to be putting in 75 newtons of force over 1 meter, which is going to give us 75 joules of force. This one, on the other hand, here, he is using an inclined plane. Now, that will definitely make it easier, but it doesn't mean that there's any less work. He actually needs to move a greater distance, but it's not going to be quite as hard. So he only needs to put in 25 newtons of force to push that as opposed to lifting it straight up, but he does it over a longer distance. In the end, it's going to equal out. So this is what you call a mechanical advantage. This makes it easy. It's much, much, much easier to get it up there, but it's not a cheat. You still have to put in the exact same amount of work. So the effort force is 25 times 3. 25 times 3 is 75. They're both doing the same work. This guy is just doing it a lot easier.